Now let's discuss what you're going to learn in this course. So the course is broken up into three big chunks. And in the first part, we're going to learn the operation of computer systems hardware and software and how they interact. Now we're going to learn everything from transistors to logic gates to the way computers are organized to instructions to software. And very importantly, we're going to discuss how the hardware and software interact, how they come together in what's called the instruction set architecture. Now, the second big part of the course is advanced performance techniques. Once we've got the fundamentals of hardware and software behind us, we're going to be prepared to look at the techniques that computer architects use to make your smartphone run so fast. And then the last part of the course, once we've learned this, is to look at the design of actual smartphone processors. And we're going to look at the Qualcomm Snapdragon processor, which many of you carry around with you every day. After we take a look inside a smartphone and cover a couple of big ideas in computing systems, then we're going to move step by step through the computing technology stack. And here's a picture of that. So this is broken up into three big pieces: digital logic, computer organization, and programming. And we're going to start at the bottom, at transistors and gates, and also talk about numbers. And then we're going to move through digital logic, which will give us some skills that we can then apply to the design of a computer. And that's the computer organization part of the computing technology stack. After that, we're going to move on to programming. We're going to see software. And we're going to see how these all fit together in the end. After we've learned about the hardware-software stack, we'll be prepared to cover advanced performance techniques that computer architects use to make our smartphones work so fast. And there's a number of techniques that we're going to cover, including pipelining, where we use an assembly line of instruction execution; superscalar, where we execute multiple instructions at the same time; multi-threading, where we may execute multiple programs within our processor at the same time; SIMD, or single instruction multiple data, which is a way to get data level parallelism, which is very important in particular applications; caches, which make our memories fast; and then multi-core, which is putting multiple processors on a single chip. Then we'll be prepared to go into the details of actual smartphone processors. Now we're going to focus on the Qualcomm Snapdragon, which is used in many Android phones. So if you have an Android phone, there's a pretty good chance you've got a Snapdragon chip in there. Now here's a diagram of the system on chip, or the SoC, for the Snapdragon 805. Now we're going to go over this SoC in a little bit of detail, but we're going to go into great detail on the apps processors. These are the main processor that runs your apps. Then we'll go into the details of the crate processor that's found in Snapdragon chips. Here's a block diagram. Now this may be very complicated to you now, but after you've completed the course, you'll have a detailed understanding of the hardware design of this apps processor. Now we're also going to do a lot of engineering design in this course. In the first part, we're going to design digital logic, things like adders and multiplexers and registers and finite state machines. Then we'll put those components together to create a working computer. And you're actually going to verify that your computer works properly by running programs on it. Now that we've seen an overview of the course, let's look inside a smartphone.